So today we're talking about radicals, and like exponents, radicals have properties that we need to know. Okay? The only thing is with radicals there are only two properties. Alright, two properties, and they're similar to the ones that the exponents had. Okay? So the first property, just as for notes, our first property is gotta zoom out a little bit, the product property. Okay. Okay. So radical is this symbol here. Okay. We normally see it as a square root, but what this is saying is the nth root of a times b. Since these are multiplied, we could write that as the nth root of a times the nth root of b. Okay. And over here in the example, we can also go from 2 to 1. So here we went from this and we split it up. Well, here we can go from it being split up to being 1. So here we have the cubed root of 4 times the cubed root of 2. Since these have the same root of 3, we can write this as the cubed root of 3. This is a 3 right here. It's not a blob. Apologize for my bad handwriting. But this is the cubed root of 3 times the cubed root of 3 of 4 times 2, which is 8. So the cubed root of 8. So all we did was these had the same root, so we said 4 times 2 is 8. So we said the cubed root of 8, and that equals 2. Because 2 times 2 times 2 is 8. Alright? So if we're multiplying under a radical, we can split it into 2. Or if we're multiplying two radicals that have the same root, we can write it as one radical. Okay. The next property is the quotient property. And like multiplying, we can do it with dividing. Okay. So here we have the nth root of a divided by b. And we can rewrite that as, and these are n's as well. So this is an n, that's an n. We can rewrite that as the nth root of a over the nth root of b. But b cannot equal 0. Okay, we cannot do this when b equals 0. Because if b equals 0, we'll be dividing by 0, and we cannot divide by 0 because it will be undefined. So over here in the example, if we have the fourth root of 162 over the fourth root of 2, or divided by the fourth root of 2, these have the same root of 4, so we can write that as just one radical. We can write that as the fourth root of 162 divided by 2. So over here we split this into 2, and here we have 2 with the same root, so we can write it as 1. Okay, and we know that 162, if we do this arithmetic, that comes out to be 81. So 162 divided by 2 is 81. And the fourth, this is a 4, the fourth root of 81 is 3. So if all of this here is just 2, it simplifies to 2. And all of this here simplifies to 3. Okay? Do you guys have any questions so far? No, it's kind of similar, it's very similar to the exponents we did yesterday. Okay. Now those are the only two properties we need to know. But we also need to know how to write radicals in simplest form. Okay? And to write, this is an E by the way, to write radicals in simplest form, we have to follow, or we have to, 3 rules have to be true. Okay? 3 things have to be true. The first rule is that no radical, I always say this wrong, but no radicands can have perfect nth powers as factors other than 1. Okay? I know that probably sounds like Chinese to you right now, but I'll explain it. It says no radicands have perfect nth powers as factors other than 1. Okay? So first of all, this right here, that's kind of hard to see. Okay. This right here is a radical, this symbol, okay? That's a radical. What's underneath it is the radicand. So in this case, 5 is the radicand. Alright, what this symbol is, not what this symbol, but what this rule is saying is that if we just have a radical by itself, it's the square root. So we're talking about powers of 2. What this is saying are that there's no perfect powers of 2 that are factors of 5. Okay? So the perfect powers of 2. 1 is a perfect power of everything, so we're going to skip 1. But if we take the perfect powers of 2, so 2 times, let me zoom in because this. So 2 squared is 4. So 4 is a perfect power of 2. Okay? Is 4 a factor of 5? No. Okay? The next one is 3. So 3 squared, that's 9. Is 9 a factor of 5? No. 9 is greater. So once we get a perfect power that's greater, we can stop. Okay? So the square root of 5, there's no perfect power of 2 that's a factor. So this is in simplest form. That's what that means. Okay? This is written in simplest form. Now for this next example, if we take the cubed root of 16 and we want to know whether or not it's in simplest form, and we're looking at rule number 1, there cannot be any perfect powers of 3, because this is the root we're using, of 3 that are factors of 16. Okay, so we want to over here look to see if there are any perfect powers. So 2 cubed, 2 times 2 is 4, times 2 is 8. Is 8 a factor of 16? Yes. Okay, so we can simplify this down. Alright, now to simplify this, we're going to use what we call a factor tree. Okay, we're going to use what we call a factor tree. What we're going to do is we're going to break 16 down using prime factors. Okay, so since 16 is even, we can use the prime factor of 2. Okay, so 2 times what is 16? 8. Okay, and then we can break 8 down again. 2 times what is 8? 4. Then we can break 4 down again. 2 times what is 4? 2. Okay, so we have broken this down to all the prime factors here. Okay, this right here, our root, tells us how many we need to group. Alright, so we have a group of 3 here, so we want to circle this. Yes, you guys may have already seen this. Okay, so since this is root 3, we're going to find a group of 3. We have a group of 3 2's, so this is what we're going to pull out of the radical. Okay, this is what we're going to pull out the radical. So this is now going to become 2. Still have the square root of 3 here, sorry, 2, and then whatever's left. So the only thing left is this 2. Okay, so that stays inside. So this is really 2 times the cubed root of 2. Okay, does that make sense? So this is simplest form. We could have done the same thing to this 5. Okay, if we try to factor that, use factor tree for the 5, the only factors of 5, the only prime factors are, besides 1, we don't want everyone to use 1, are 2 and 3. We can't factor that out anymore, can we? Are there any factors of 2 other than 1? No. Of 3 other than 1? No. So we don't have a group of 2 to pull out. So this is simplest form. This here is in simplest form, okay? So that's the first rule. First rule, we want to see whether or not there are any powers. Okay? If you look here, 2 times 2 times 2, that's the 8. That's the 8 that we pretty much pulled out. So that's the first thing we want to do. We want to use factor tree with the radical to see if we can simplify it. Okay? The second rule and the third rule a little bit are easier to check. Okay? Those rules, zoom out again, not that way, this way. The second rule says that no radicands can contain fractions. Okay, so that means no radicals can be under the. These rules are quick, so you'll have room. Yes. There's 3. So the last 2 rules are relatively small, so you should just try to fit it on there somewhere. Okay. So this is saying no radicands can contain factors. So all that is saying is that we cannot have a fraction under the radical. Okay. We just have to simplify it. If this is the case, we have to simplify this. Okay. The third rule is that no radicals can appear in the denominator of a fraction. Okay. So if we have 1 over or 1 divided by the square root of 4, we have to simplify this because the square root of 4 is in the denominator. So these are 3 rules that we have to check to see whether or not a radical is in simplest form. Okay, so today you should have all of this for your notes. We're going to use these properties and the rules for simplest form to work some problems. Okay. So what I'm going to do is I'm going to work a couple examples that you will see on your homework. Okay. Okay. So the first 2 examples, or your first part of homework, problems number 15 through 19, okay? Those problems, those are going to involve the first 2 properties. Alright, so you might see something like this. Okay, you might see something like the cubed root of 4 times the cubed root of 128. Okay, I'll zoom in because that's kind of the cubed root of 4 times the cubed root of 128. Alright, first thing you want to do is take the cubed root of 4. Okay, you guys might need your calculators today. Alright, so if you take the cubed root of 4, you're going to get a decimal. If you get a decimal, you want to leave it as a radical. Okay, if you take the cubed root of 128, you'll also get a decimal. So with these, you're going to leave these as they are. Alright, now you're going to look at your properties. Right now this is this radical times this radical, and the radicals have the same root. Okay, so we can use our product property. We can write this all under one radical. So this equals the cubed root of 4 times 128. Okay, this equals the cubed root of 4 times 128. What is 4 times 128? Okay, it's 512. So we can rewrite this as a cubed root of 512. Now, before we want to write this in simplest form, we can plug this in our calculator and see if 512 is a perfect power of 3. So basically, we're going to take the cubed root of 512. Okay, if you plug that in your calculator, you should get 8. Okay, and 8 is our answer. If this happened to be a decimal, we would then want to use or we would then want to, we would then want to use a factor tree to write this in simplest form. But this happens to be a perfect power, so this is our answer, 8. Okay, so here we use the product rule. For the other problems on fighting, I just said fighting. Yeah. Okay. Are we beefing? Are you beefing with me? Okay. Alright, so the next example you might see is the quotient property, okay? So the quotient property is when we see division. Okay, so here we have the 5th root of 192 over the 5th root of 6. Okay? Okay? So if you see this on your homework, the first thing you want to do is take the 5th root of 192. Alright, well that's going to be a decimal, so we want to leave it. Same thing with 6. It's going to be a decimal, so leave it. So now we want to look to see if these have the same root. Well, these both have a root of 5, and we're dividing, so we can rewrite this all under one radical. So it will become the 5th root of 192 divided by 6. Okay? Well, 192 divided by 6, that equals 32. So this is really the 5th root of 32. Okay, this is a 5. Okay? And really, the 5th root of 32 is 2. And that's your answer. But if you took the 5th root of 32 and it was a decimal, we would have to use our factor tree to simplify this radical. Okay? In both cases here, we got lucky. We got nice, pretty answers. Alright? So this is what you might see in problems 15 through 19. Alright, now I'm going to work two more examples, and these are ones that you might see in problems number 21 through 25. Okay? Okay. So here we have the cubed root of 500. Okay, and we're asked to simplify. We're asked to simplify the cubed root of 500. Okay. Now, if we look at our 3 rules, rule number 2 and 3, they have to do with fractions. Are there any fractions here? No. Nay, no. Nope. So we don't have to look at those 2. Okay? So since we don't have to look at those 2, we have to look at the first one. And we want to use factor tree. So we want to simplify this now. Okay? So if you use the factor tree, I don't know, 5 looks kind of nice. 5 is a pretty prime factor. So 5 times what is 500? 100, okay? This is root 3, so we're going to be trying to find a group of 3, okay? Well, we can break 100 down by 5 as well. What times 5 equals 100? Yes, 20, okay? We can break 20 down by 5 as well. So it's 5 and 4, okay? Can we break 4 down? 2 and 2. Can't break the 5 down, so we get 2 and 2. Okay, do we have a group of 3? Yes, right here. Okay, so we can pull out a 5. Okay, if we factor out a 5, we get 5. We still have the cubed root, okay? And underneath we have what's left. So we don't have 2, 2. This is really 2 times 2. Okay, because they're factors. So what's 2 times 2? 4. So this simplified is 5 times the cubed root of 4. Yeah, it's not bad, is it? Nah. Nah, bruh. Nah, bro. Nah, brother, man. Okay, I guess I'm not funny today. Sigh. Sad day. Okay, so that's one example you might see. The next example you might see, does that make sense? First of all. Okay. So to simplify, if we aren't dealing with fractions, we want to use the factor tree. Okay. If this happened to not work, then this would be in simplest form. Okay. If there was no groups of 3 here, there was just 2 5s and 2 2s. Since this is a 3 here, this would have already been in simplest form. Okay. So the next example you might see something like this: the 4th root of 19 over the 4th root of 4. Okay. Here we do have a fraction, so we want to look at the second and third rule. Okay. The second rule says that we do not want a fraction under the radical. Well, here we have no fractions under the radicals. We have 19 and 4. The third rule says we do not want a radical in the denominator of a fraction. So we have a fraction, and in the denominator we do have a radical. So we want to simplify this. Okay. Now the way you simplify this is you want a perfect power of 4, because we're talking about powers of 4. We want a perfect power of 4 in the denominator. Okay. The perfect power of 4 in the denominator will get rid of the radical, and I'll show you why. So I'm going to go ahead and take this step, and I'll explain backwards. Okay. I'll work backwards because I believe it makes more sense that way. So I'm going to multiply by 1. Okay. We'll multiply by 1. Would you agree with me when I tell you that this is 1? Yes, because we have a number over itself. Okay. It's like 4 over 4, or 5 over 5, or 1 over 1. This is 1. Okay. Why does that look like that? I don't know. Okay. So we know that by a product property, okay, these have the same root. So we multiply, just multiplying the denominator here, we get 4. Okay, the 4th root of 4 times 4, which is the 4th root of 16. Okay? These have the same root, so we can just put it all under 1. Okay, so it's 4 times 4. And 4 times 4 is 16. Well, what is the 4th root of 16? Well, 2 times 2 times 2 times 2 is 16. So the 4th root of 16 is really 2. So now in the denominator, we don't have a radical. So when you have a radical in the denominator, you want to make the denominator a power of 4. Okay, a perfect power of 4. 16 is a perfect power of 4. And I can make 4 16 by multiplying it by 4. Okay? So we want to make sure, since this is under root 4, I have to multiply this by the root 4 of 4, so that the radicals match up. And since they match up, I can write it under 1. 4 times 4 is 16. 4th root 16 is 2. Okay. So now I just have to worry about the top now. Now I have to focus on the top. Well, the top, we don't necessarily care whether or not it's a perfect power. Okay. We just want the denominator to be a perfect power. The top, whatever we get is whatever we get. Okay. So this we can rewrite as the 4th root of 19 times 4. 19 times 4 is 76. So this is the 4th root of 76. Okay. Now, if we take the 4th root of 76, we will get a decimal. So that means that we have to check to see if this is in simplest form. Okay. This radical on top. So we have to use our factor tree. So over here as side work, we're going to use our factor tree for 76. Okay? 76 is an even number, so 2's are always easy. Okay? So 2 times what is 76? Two times what is 76? Close. 38. 38. Okay? 2 times what is 38? $19. Okay? Is 19 divisible by anything? No.